Hey and welcome, my name is Gijs, and in this video I'm going to explain you very briefly how this electrical system works here. We have an inverter charger, a DC-DC charger, an MPPT charger, a Victron Cerbo GX, a 12-volt distribution panel, a links distributor, a main switch and a battery monitor. So this system behind me is made based off this diagram. And I'm going to explain to you now how everything of this works. If you have any questions, drop them in the comments. Let's get started. So the first thing I'm going to explain is the household battery and the connection points over here. Here we have what it's called a links distributor. And basically what this is, these are two metal strips on which you can connect certain lugs. So for example, this one goes to my inverter charger, this one goes to my DC-DC charger, this one goes to my MPPT charger, and this one goes to our 12-volt fuse box over here. We are using a busbar system because we don't want to use the battery poles for more than 2 connections. So in this example, I've connected a 95mm wire from the negative pole all the way up to here to a battery monitor, and then to all the negative wires of my devices. So the battery monitor is going to measure how much energy there is going in and going out of the battery. From the positive pole, we have a marine rated battery fuse or an MRBF fuse, which is connected to a main switch and then connected to the positive strip of the busbar. So, and from this positive pole, we connect our devices. So here we have a few fuses. I'll start explaining with the first one. So here we have an 80 amp mega fuse with a positive wire which is going directly to our 12-volt distribution block. Beneath that is a negative wire which also goes to the negative pole of our 12-volt distribution block. So from here you can connect your fridge, your LED lights, your diesel heater, etc. So that's the part of the 12-volt distribution block. Next up is this 60 amp mega fuse, and this one goes to my solar charge controller. So from here the red wire goes all the way to this one. Here says battery and a plus sign. So we take this red cable and connect it to the plus pole of this MPPT charger. The same goes for the negative pole or the negative wire, which is located behind here. It goes all the way here and into the negative terminal. So this says PV, and here you can connect your solar panels. So the only thing I did is select some cables with some MC4 connectors because unfortunately I couldn't provide a solar panel for this setup in time. Next up on the line is our DC-DC charger. So again we have a 60 amp mega fuse, and we take the red cable and we connect it to the output of our DC-DC charger. And beneath here is the negative wire, and the negative wire we are going to connect to the output and to the negative wire. So the positive and the negative go to the output of this DC-DC charger. The input, also a red and black wire, the input positive pole, we connect to our starter battery with a fuse, and the negative cable we connect to the negative pole of our starter battery or to the common ground. So this is an isolated charger which has 2 negative wires. You can also install a non-isolated charger, and then you have 1 common negative wire. So last but not least is our inverter charger with a 400 amp mega fuse. Is connected with a 95mm wire here to the plus pole of the Victron MultiPlus, and we have also a negative wire, also 95mm, going all the way back here. So connecting the wires to your battery with a bus bar is relatively simple. You just connect the positive and negative pole to a decent bus bar and then you're fine. You just make sure you use the correct wire size and the correct fuse size. So this is an inverter charger. So because this is an inverter charger, we also have AC in and AC out. So we have AC in, which is shore power, so an external power source which can charge our household batteries. And then we also have the AC out, so that can provide energy to our devices inside our camper van or boat or overlander or 4x4. And that works as following. I've tried to make it as visually easy to understand as possible. So this yellow wire here on the right side is the AC in, as they call it with Victron. And this AC in wire goes all the way to here. I had to connect some leftover wires. It's going through an RCD into our shore power inlet. So what happens here, I can connect my shore power and my Victron MultiPlus will turn on and charge this battery. I'm not sure if you can hear it, but it is saying here bulk, and we are here now charging with 99 amps, 130. So that's what happens when you turn on your AC power. Then we have the AC outs. So here we have some outlets, and you can see these as the outlets inside of your camper van or boat or overlander. And they are connected the following way. So now we have this wire here, the upper yellow wire, which is connected to the AC out of the Victron MultiPlus. So the AC out goes here, all the way here, also connected. So this is basically the same wire, also going through an RCD and then going into your outlets over here. And that's basically how it works. So the last thing I'm going to explain is the Victron Cerbo GX. This is a monitoring device from Victron, and which makes it very easy to monitor your whole system. You can basically monitor your inverter charger, your MPPT charger. You can also add your new Victron Orion XS. I have an older model which can't be monetized. And how it works is quite simple. First we need to shunt this device. This can measure all the ingoing and outgoing current. This shunt is connected with a VE direct cable to the Cerbo GX, so it can communicate with each other. Then we have two cables over here, which is a USB and an HDMI cable, which is connected to the screen. Here we have another VE direct cable, which is the communication cable of Victron, and is going to the solar charge controller. So if I had solar, we could see here on the screen how many watts of solar I would be harvesting right now. I don't know if it's the right word, but let's call it harvesting. And if I would to have a Victron Orion XS, I would also be able to connect it with a VE direct cable. And I would also be able to monitor how much energy I'm generating with that. Then we have our inverter charger, so our Victron MultiPlus. We use a VE bus cable for that, for the connection. So here we have a VE bus connection on the Victron MultiPlus and on the Victron Cerbo GX. And that enables you to use the MultiPlus from this Victron Cerbo GX. So for example, I can say, okay, the MultiPlus is now on charger only mode. I want inverter only mode, or I want to turn the MultiPlus on. That's where you need this cable for, so it can communicate together. So that's basically a very brief explanation on how a off-grid electrical system works. So as I said in the beginning of the video, this installation is made based on our wiring diagram software. It's very easy to use. It calculates the correct wire size, it calculates the correct fuse size. It works with 12 volt, 24 volt, 230, 120. And if you purchase the software, we'll send you an ebook of around 92 pages in where I explain how off-grid electrics work. That's basically it for this video. If you have any questions about the electrical installation or other subjects regarding off-grid electrics, or you want me to make a video about something else, regarding this, please let me know in the comments. If you enjoyed this video, you can leave a like, you can even subscribe if you want to, and then I'll see you in the next video. Thank you for watching.